Welcome to a new test and teardown video. This time it's another IMPO electronic. IMPO made electronics products like this for schools back in the 70s and 80s. So this one is 50 to 40 years old. It requires a little bit of a deep wash. So I'm going to do that in a minute. And there is a very special smell to this. And I've been looking through here and it looks very much homebrew and funny old. So I think I should definitely open it before I just power it on. We don't want any big kabooms here. It is definitely a dual power supply. I think it's completely separate. But I think we got the outputs, they are kind of wired back to the outputs in the front. Or is this sense to the back and then we just have the outputs on the front? I really don't know yet, but they were a little bit loosey-goosey here. But now they're quite all right. So I will have a look inside. Inside IMPO products, you normally find a sticker or a stamp or something with the date 1968. Isn't that funny? This is kind of a rule they made, so it's always there. I really think this is two completely individual power supplies, two transformers, and everything is completely individual. I do see a little bit of wires between the two transformers down there, but I think that is probably just mains or something. But why is one bigger than the other? That's also a little bit weird. Because the specifications should be 1 amp and 0 to 25 volts for both of them, right? And then I can change the amp meter 0.1 or 1 amp. I tried with my ohm meter to check the two individual power supplies and there is no connection between them. But the output of the two power supplies, one is very low resistance and one is high resistance. So, I mean, it's probably not going to work. But how about we just power it up and see what happens, all right? So now, let's power this up. 14 watts. I think it's a little bit funny with the two bulbs, but that one is working. That is the power on bulb. 14 watts and it's still 14 watts, so I'm not that scared. Ooh. Click. What the heck? There is a relay. Okay, this pot is just completely dead. Oh, look at that. The output voltage is preloaded with a bulb. What the heck? Why a bulb? And then, is it that one? Yeah. So here's a relay. So there's a tap on the transformer. Okay. And the voltmeter here is already getting better. Look at the amp meter. Yo. So how about we try the other one? Same. And here's also. Ha! So this power supply actually works and it's 55 years old or something like that. Okay, I'll have to play a little bit more. I want to try and load it. I want to try and see the ripple. Yeah. So I've been playing a little bit more with this power supply, and it definitely seems to be working. See, I've set a load for 900 milliamps, and at 0 volts, of course, we have 0 amps. This power supply actually goes to 0.0 volts. That is great. See, just a tiny little volt, and then we get our load. And if I crank the voltage up to about 9 volts, can you hear it? So at exactly 9 volts is this relay. See, here's the relay is activated, and that means, of course, the voltage from the transformer we take to different windings. So let me show you what happens. I am now just under the tapping. So let's look at the input power is 35 watts and the output is 9 volts and 900 milliamps, so that is 8 watts. So what if I crank up the voltage, just click. So now the output is 9.2 volts and it is 8.4 watts. And see what happens with the input power, 57 watts. And that is how it is with linear power supplies. We got quite a lot of high voltage on the capacitors, so that is of course how it is. We'll heat up those transistors. It is a little bit funny with the different transistors here. We got a 2N3055 right there, and then we got a germanium 8132, and that is not running warm at all. This one is ice cold, and this one here is running a little bit warm. Not a lot, but enough to tell me where those watts are going, because I'm not loading anything else. So it is that one. Also, if we look at the output ripple, so I am now in AC mode. That is 200 millivolts per division. See when let's do it like this so you can see what I'm doing. See when I turn up and down the voltage. It was supposed to be a smooth transition. All this noise you see here. See? If I continue to go up. That is pot meter noise. And of course the pot meter definitely needs cleaning or replacement. The more I use this pot meter, the better it is. Now it's actually looking quite nice on this voltmeter, see? Nice and smooth. And it's actually super stable. And look at that ripple. There is nothing. And this is almost full load. And let me get down to business here. 5 millivolts. That's it. And this is turn off the load. And here we go. Load off, load on, load off, load on. That is very impressive for a power supply this old. Regulation is super duper tip top. It definitely works. Here is the regulation. Got all those diodes. I think that is an auxiliary voltage. We got germanium transistors, and that is the bulb for loading. Some more diodes and capacitors. I think this is the main charge capacitor, And it definitely works. And there's another relay down here. And here's also a relay. Some capacitors and stuff. And for the metering, see, this is how you calibrate your voltmeter. And then there is this switch to select between 100 milliamps and 1 amp full range. And those two trimmers, that's of course the two ranges for calibration. Super, super nice and simple. It's so easy to find the trimmers and to figure out how to calibrate this thing. Yeah, I'm actually a little bit happy about this layout. It's not that dumb. But imagine this was a product made for a school or something, and it was made in a company and sold like this. And it's made on prototype board. That is a little bit fascinating. They managed to pull this off. And I've been looking into many IMPO products. I think this is my 8th IMPO product, and many of them looks like this, prototypes and funny stuff. How did they pull this off? How did they manage to make them and sell them in this kind of prototype kind of state? That is a little bit impressive, isn't it? So with that will be my final words for this video. See you tomorrow. I hope you had fun. Bye bye.